Hey scholars, welcome to the last section of chapter 2, looking at 2.5. What are systems and how do they actually respond to changes? And so we're going to take a look at a few things today, and the first one is what is a system overall? And it's made up of 3 parts, and the first part is actually the inputs, and those usually come from the environment in the form of actually matter resources like sand or gravel or some sort of rock material, possibly an energy source like a fossil fuel or a natural gas or something like that. Then you have the inputs obviously get put into the system. Those are the materials that make up the product which you guys have been working on or have worked on for your P times A times T equals I project. And then you have the flows or the throughputs. And that's like the actual economy where the product is being sold. You know, it's already been made through the inputs and then it's being sold to the market and being used by the consumer. The outputs are either the waste or the heat that's given off from that specific product, or the goods and services themselves. Those are the outputs of it all. So the flows are the throughputs of the economy, the exchange between the actually producer and the consumer, and then the outputs are the actual use of that product and also the waste it puts out, or even the waste that after it's done with and discarded. That would also be an output as well. So let's take a look at an image of it just to kind of look at those three things. This is the whole system in general. You have the energy inputs, which are energy resources, could be matter resources or information. You all put that into the economy itself, which is the throughput, and then eventually the outputs are the heat, waste, and pollution, goods and services that are kind of excreted by, I should say, the product itself that you're actually purchasing. So there's a couple of different types of ways systems respond to change. And it's through feedback loops. And there's 2 different types, and these would be very, very imperative for you to know what they are and some examples of these for your next quiz coming up. And the positive feedback loop is where it causes the system to change further in the same direction. I kind of think of this like the domino effect. In the case study, it looked like this, where you actually had the vegetation. We decreased the vegetation, which led to erosion and nutrient loss, which then led to further degradation or decreasing vegetation. And then more vegetation became a die, and then it just became kind of an abyssal, desert-like area around the river. That's an example of a positive feedback loop. It keeps going in the same direction, just like a dominoes would. That's one example. The negative, or what we call the corrective feedback loop, is where it causes the system to change in the opposite direction, which is from which it's moving. It's kind of going against the grain. This is like the thermostat, and we'll explain how the thermostat works here in just a second. So let's start off. Where we're actually cooling down a house. So the house temperature reaches desired setting and furnace goes off. That's our starting of it. So then we set our temperature. So the house is going to be cool. So we're trying to heat it. Set this winter time where we're heating our house up in the winter time. So 70 degrees, what we're looking at. It's there as the heater turns off, and eventually because heat escapes and heat rises and it's lost by the house. Eventually that temperature in the house cools off again. So the house is cooling. So the temperature drops below that desired temperature, and the furnace goes on again, so going against the grain again, not going towards the cooling, but now it has to go against the grain and warms it up, and then eventually it stops again. So it's kind of going back and forth, kind of working against itself as far as the negative feedback loop goes. That's just one example there. Let's take a look at some other things that we can learn from. The other examples might be, like, for instance, areas once thriving vegetation turn to deserts because, like you saw in the case study, we deforest an area. Eventually the nutrients are lost enough, and that just keeps going in the same direction where we actually go from once having lots of vegetation to none whatsoever. Another example is coral reefs dying because of climate change. Global warming is a perfect example of a positive feedback loop. The more fossil fuels we burn, the warmer the atmosphere gets. That also, coral doesn't do well with warmer water, so that's going to heat up the water. Coral dies, which also releases more CO2 into the atmosphere and things like that. The water itself, the oceans can't hold that CO2. So in the CO2, that's a greenhouse gas, increases global warming even further, and continues that cycle. That is another example of a positive feedback loop. Some other things that we want to talk about are time delays. Time delays vary between the input of a feedback stimulus and the response to it. So for instance, in planting those trees, if we go back to this case study that we saw here, the actual time delay is that, let's say, from right here and right here, we want to start going ahead and planting more trees to rebuild that area. The time delay is the fact that it necessarily, might not. It's going to take some time for those nutrients to rebuild itself in order for you to plant trees. So that's what we call by a time delay. It's basically like scientists could plant trees in a degraded area, such as this experiment, to slow the erosion and nutrient loss. That just would help with kind of slowing down the positive feedback loop in general. Another one is called a tipping point or a threshold level, and this causes a shift in the whole behavior of a system. And like in the case study, if too many nutrients were lost from the soil, and those scientists wouldn't have an opportunity to replant trees because those trees would not live and survive because there's no nutrients to support them. So that's what we call a tipping point or a threshold level, where if finally there is a whole shift in the behavior where there's no really coming back from it unless you do some major input work. Also, if you think about this case study, if going back to this section right here, if at this point there was enough nutrients there, the nutrients were there at least a little bit, and scientists did plant trees and the forest rebounded, would this be a positive feedback loop? Not necessarily. It would be a negative feedback loop because you're going against the grain, restoring the forest to where it originally was. Now, the whole word positive, negative, that's easily to get confused on, so don't get thrown off by that. The positive feedback loop in this case is not really a negative, it's a negative thing overall for the loss of habitat. So I don't want you to get that positive as in good, don't get those, don't correlate those two. Positive meaning going in one direction, negative meaning going in the opposite direction. So don't get those two things confused. All right, another thing we want to talk about is synergistic interaction or synergy. This is when two or more processes interact so that their combined effect is actually greater than the sum of their separate effects. So like, two heads are better than one. You get a better product if you're both thinking about the same thing on the same page. Rather than working separately, you might not get nearly as an efficient product or an outcome. So helpful things, writing a letter to an official to vote for a new environmental law might make some change, but if you persuade a group of potential voters to get somebody in there who is going to make a bigger change, that might have a better impact. Or if you got more people to write a letter to that one person, that might have a bigger impact. So again, two heads are better when that's the helpful situation. The harmful would be like if you smoke and you are living in an area that has a lot of asbestos particles floating around. That's a double whammy for lung cancer. So both those things combined, you have a greater chance of getting lung cancer and probably more damage done to your lungs. All right, so last thing we're talking about today is that human activities, again, have had unintended harmful results. We've had once thriving vegetation turning into desert because we deforested, tried to do some planting, and it just didn't work out for us because of erosion and nutrient loss. Coral reefs dying due to pollution, climate change, offshore dredging and drilling, glaciers melting from global warming because of our fossil fuel, and the same thing with sea levels rising. So those are just a few of the different human activities that can have unintended harmful results just from a bunch of things kind of combining, like global warming, fossil fuel emissions, pollution, climate change, causing coral reefs to die. So those are all more, I guess, examples of negative synergistic reactions. All right, that's the end of chapter 2, guys. We'll see you guys next time for chapter 3.